So this is part two, tuberculosis in social contexts, and here you'll notice that when, as you read this, is he looked at when Dr. Trudeau talked about this, he distinguished, one of the things he did when he did this experiment is distinguish between a helpful therapy and a cure, right? So there is a difference between a cure and a therapy. You know, a lot of you say you want to be doctors and nurses and etc. This is a kind of one of the beginnings of your understanding of the difference in disease when we're dealing with a therapy versus a cure. There is no cure for sickle cell, for instance, but we can treat the symptoms. There's all kinds of things we can do. Yeah?
Sort of like cancer and chemotherapy? Would that be a good example of the difference between a cure and therapy?
It can be, because cancer often just goes into remission. What that means is we kill the cancer cells, most of the cancer cells, and it stops being a problem. But the cancer is likely, well, not likely, different cancers have different likelihoods, and it depends on the individual, but the cancer can come back, yeah. So do you cure cancer, or is it a therapy? It's really, you actually picked one of the gray area ones really to talk about, yeah. So a good example of that is malaria. We can get rid of the malaria parasite, most of it, but some of it will be hidden in your liver and your symptoms will go away, but you'll come back. Mononucleosis, the kissing disease, right? Herpes, a virus that you have for the rest of your life once you have it, right? You can treat it with different drugs that calm down the infection, but it'll come back when you're stressed out because it's always there. Chicken pox. There's a number of issues that arise that you really never cure, and tuberculosis is one of those. You can take the drugs, the cure, we have a cure now, but back then it was just a therapy. It's just like, let's help with the symptoms. He opened the cottage, a sanitarium. It was a sanitarium. Now this is key because as you go ahead and read in your literature, you'll find that the word sanitarium is used a lot during the early writings. Anytime before 1943, where people went to when they got tuberculosis were sanitariums if they had the money to do it. Yeah, that's it. So the benefits of fresh air and sunlight and rest and nourishing food were obvious to him from these experiments. So here's your question. The curve shown in figure 2, and there's figure 2, and people had trouble analyzing this curve, right? The curve in figure 2 has 3 parts. What are the 3 parts? What are the 3 parts they give you, they talk about? They say 1700 to 1800, right? You agree? Is that part 1 or not? Yeah. So this is part 1. Then 1955 to 85. That's the second part of the curve. Do you agree?
Yes.
How many of you labeled your notes this way? When you had your hard copy, how many of you did this? Made little notations in the text? Okay, good. So this is a learning process, so now you know. When you're doing this, you should go ahead and identify where are these 3 parts that they're talking about it before. Did I even look at the graph yet? No, I'm just reading. This is called reading for understanding, right? This is how we identify what is important and what isn't. Yes? But you can, instead of writing on it, you could have taken notes on it, right? You could have said part 1. What would you have done if you couldn't write on it? And I could write on this, that's why I did. But you could have said part 1, 3 parts, right? How do you take notes? 3 parts, part 1, 1700 to 1800. How many people think this is too much work to do this? All right. I'm glad to see that people don't think that. 1955 to 1985 is part 2. And what's part 3? 2000 to 2005. So those are the 3 parts we're talking about. Now it's key that I have to make sure that I identify what those 3 parts are. Question?
Why does it say up there next to part 1, 1800 to approximately 1955?
Oh, that looks like that's part 2. Yeah, messed that up, didn't we? So part 2 is actually what? 1800 and 1955. And part 3 is what? 1955. Thank you. Good?
Yeah.
All right. So those are the 3 parts we're going to look at. So then it says, the data used to produce the curve are from Western Europe. So we know it's from Western Europe. But a similar one could be expected from the United States. From what you know of the history of and culture of the United States and Western Europe, write a sentence telling why each part of the curve looks the way it does. In looking just at this graph, what would you predict about the death rate of TB in 2000 and 2005? So the first part of the question is asking you, so there's 2 parts of the question, what we know about the history. We talked about the history, right? We talked about the history of the United States and the Western world a little bit. And it says, tell us why, write a sentence telling us why the part of the curve looks the way it does. And then the second part of this is that they want you to predict the death rate in 2000 and 2005. Well, part 1, 1700 to 1800. All right, so here's 1700. Let me go ahead, use red. There's 1700, there's 1800. So this is part 1 right here. Do you agree? So this is part 1. So what's happening with TB in part 1? It's going up. The death rate per 100,000 is actually increasing. Why do you think that's happening between 1700 and 1800? What's happening in the United States during this time to the population of the United States? Yeah?
I'd say more people were becoming exposed and they didn't yet have cures and therapies for it.
Very good. That's perfect. There more and more people are but why? Why are more and more people being exposed? What's happening between 1700 and 1800? Yeah?
Well, aren't more people coming to the United States at that time? Same with the Industrial Revolution starting.
Right.
So they're having less fresh air and then more people are coming, so it's becoming overcrowded in the areas along the East Coast.
That's right. We're getting more and more people moving into cities. More and more people coming into this country. That's right. But what else happened? That's one thing, is increase in population. I'm not going to write the sentence, but I'll write the factors. There are more people in cities, so the density is bigger, right? Less and less people in farms. And so what's the third thing that happened between 1700, listen to what I'm saying, 1700 and 1800, what happened? Something else that would increase disease, pestilence. We're the 4 horsemen of the apocalypse. Yeah. What are the 4 horsemen of the apocalypse? Pestilence, disease, right? Pestilence, what else?
Death, war, and...
War. What was the war?
World War.
It was a Revolutionary War in this case. 1776. The Civil War didn't happen until when? 1860 something. All right, everybody agree with that? All right. So then in the 1800s, around 1800s to, what was it? To 1955, what was happening at that point in this section from 1800 to 1955? What happened? Was it decreasing or increasing? A decrease. And what was happening during, what improved in the way of life for people between, somebody mentioned it a minute ago, that decreased that decreased this disease, this spread of this disease? In the back? Go ahead.
Oh, they were starting to find like new medicines.
Not, in 1943, yes. We had medicines here. 1943, somewhere around here, there was medicine, right? Something happened before medicine, though. They started decreasing tuberculosis. Yeah?
Sanatoriums.
Sanatoriums. Which also, by the way, had the added benefit of separating the sick from everyone else. So sanatoriums, and the other thing that happened is better conditions, better living conditions. Why did people move into cities? Because you have indoor plumbing. Because you had places to wash up. There were sewers. You got rid of your poop, right? And that increased the environment. Yes, there were negatives as well, right? But the Industrial Revolution allowed people to live better. There was more food available. So better living conditions. Remember we said that the better living conditions, the conditions are, the more you can resist disease? And so we see more and more of this. And of course, once the medicines hit and you had better living conditions, what happened to the death rate? The death rate decreased and you had much more survivability. And so what you ended up with is a big drop, a serious drop because of medicine, because of living standards. And as I keep telling kids, we are spoiled. Our generations, from my fathers to us, to you guys, we've all been spoiled. We don't know what these people were going through. We don't understand what these people were going through before the advent of these medications. Because it wasn't just this. It was cholera, smallpox. It was the Spanish flu. All this stuff was hitting these people over and over again. Death was something they dealt with all the time. So much so that kids sung about it on playgrounds. Ring Around the Rosie. Yeah, Ring Around the Rosie is about ring around the Rosie, the little ring that goes around smallpox. People have smallpox. Right, ring around the Rosie, pocket full of posies, ashes, ashes, we all fall down. It's because they burned the dead. Yeah.
Was this around the time where the Great Depression happened?
Was this what you think this spike here was like in the 30s or something? Yeah, that might have been. That's a really good idea. I don't know why there was a spike there, but that really is that's a fantastic guess, right? Great Depression, right? The Great Depression, people have less food. Do you see how much information you get from a graph? It's amazing. Look at all this we figured out from a graph. Without ever, has anyone here seen anyone with TB? Have we seen any patients? No, we just have collected a bunch of data. By the way, you probably have seen people that have been exposed to TB because it's still around. You have a question?
If your answers are close to like what we talk about, do you have to rewrite it and put everything that's on there? Or
I would make sure I understood this, because here's what's going to happen on the test. You're going to get a graph. I'm not saying you're getting this graph, but you'll get a graph like this, all right, and you'll be asked to analyze it. And so you should be able to say, and here's the question I have for you, and here's my concern. I don't want you to leave here thinking, well, I understand what he's saying, so I don't need to write it down. You can understand what I'm saying right now. That's great. You can understand that all these factors impacted this rate, and that there's a decrease here, and that this spike was probably due to or could be due to the Great Depression. That's fine. That's fantastic. Guess what's going to happen tomorrow when you wake up? You forget everything. You won't remember. Come next Wednesday, you're taking the test, and you're going to blank out, aren't you? How many people have done that? I'll raise my hand. I've done it. I've done it. I blanked out on tests. But why do we blank out on tests? Because we haven't reviewed this material. So if you're writing it down, those of you who are laying your heads down and not writing it down, you're not going to remember what was important. I mean, you won't remember it. You're gonna go home to quote unquote study, and you're just gonna read the notes you've already taken, and you'll forget all about the conversation that we had right here and now. Which is why it's important that you write this stuff down. In your notes at least, so you can review it. Is it important that you correct it and resubmit it if you're close to these answers? That's up to you. I'll read them and I'll judge it. I'll grade it for what it is. And if you want to wait till after I grade it to do it, my concern is that here's a big warning to you. Don't wait till the last minute, because then I give you another assignment, and then things get backed up and you never correct because you never have time. Does that make sense? So, all right. So let's move on.
Wait,
Yeah?
under medicine, what did that say?
Say what now?
Under medicine, red, what did that say?
Oh, increased living standards, and increased medicines, right? That's why this dropped, right? You agree? All right, so now let's take a look at this other part of this question. Predict the death, what's going to happen to the death rate? Okay, so this is kind of a trick question. And why is this a trick question? Because it's not a trick question, but some of you are going to think it's a trick question. A lot of you are just going to extend the line, right? You're just going to say, well, if things keep going the way they do, then what's going to happen is, we'll get to zero by the time, right? A lot of people would do, look, I extend the line. If this trend keeps going the way it is, by 2000, it's going to be at zero. Do you agree?
No.
What don't you agree with? That's it.
That is that.
Why? Why don't you agree with it? I agree that it's no. I mean, it could be zero. It could be. It's likely close to zero, but it's not the best way. You could extend the line. You could say, look, I'm going to extend this line. And I'm going to, wherever this line ends up, I'm going to say that's where the death rate's going to be from TB. But is that realistic? When you have this, because what I'm doing if I do that is I'm assuming that these conditions here are going to stay the same, and I'm ignoring most of the data, aren't I? I'm ignoring this whole thing here. If I just extend this line, I'm ignoring that whole thing there. And maybe that's okay. Maybe we say, well, the conditions are going to do nothing but get better, so I'm going to go ahead and assume. Right? We can do that, but we have to be cognizant that we're making that decision. We have to be honest and say this could be an error. So if you're not paying attention, you're just picking at your nails, I don't know what to say about that. All right, so what's a better way of handling that? What's a better way? Who's done best fit lines in middle school? So some people have. You've done that in Mr. Custer's room?
Yeah, but I'll take it.
No, that's good. You should do best fit lines. And there's this term called, write this down, linear regression. Fancy word, linear regression. And you don't need to understand the details of it, but linear regression, you're going to do that later in high school. In advanced math. And what linear regression is a fancy word of saying best fit line. All right? And all a best fit line is what can I do? It's a fancy word, but there is a formula for it, okay? It is a mathematical there's a mathematical definition. What I'm telling you is that basically it's the same idea as a best fit line. And what you do is you look at all the data and you try to find through various mathematical techniques, you try to find kind of the average of all the data and say, if this is the trend. Another word for it, by the way, is trend line. What's the trend line? Now, the trend line can take all different kinds, and I'm not going to get into this, but just to let you know, it can be linear, it can be logarithmic, it can be all kinds of things. But we're going to go ahead and assume in ninth grade that it's going to be linear. All right, so it's going to be what if I were going to draw a straight line. what's the line that would represent the trend of the entire graph? And so what I do is I choose 2 points on the graph, and it's kind of a guess. It's a good guess, right? And some people might have different people have different things, but most people would have the line decreasing. Do you agree? It might be different slopes, but so if I were to draw a trend line, now you could also, by the way, you can do it much better with Excel. If I were to draw a trend line, I would probably draw something like, give me a second, something like that. That's my best fit line. That's the trend line. So this is the linear regression, and the reason we call it best fit line is because I just kind of drew it in there. If I did it mathematically and I had Microsoft Excel do it, it'd give me a much more accurate result. But this is called the best fit line, or also another word for it is trend line. And so now I can make a better guess because I'm taking all the data into account of what would it be in 2005. Now you remember if you watch the video, if you haven't watched the videos yet, you'll go back and you'll look at it. You'll see me making the scale on the x-axis, and I tell you, here's what I saw people do. I'm going to go ahead and sketch this out. This is what I saw people do when they went to go graph the data on that scientific method. They had their graph here like this. They scaled it. They put the different numbers to the scale, right? And then they put their maximum number here and maximum number here. And so their line went something like that. And that was it. They were done. Did they get all their data on the graph? Yeah, they got it in there. But what's the problem? What about all this space? You just wasted it. On the other hand, if I would have divided it so that the line goes all the way, the maximum value is close to the end here and close to the end here, then if I draw that line, it fills up the whole graph. So one of your objectives is to fill up the whole graph. The other objective, and you'll see, that's not even the best way of doing it, because if you divide it so it takes up most of these lines, so your max value is here, your max value is here, then when I draw that line and it ends there, what can I do? I can predict the future. I can predict what's going to happen over here even though I don't have any data. So when you're looking at a graph like this, it's really nice to be able to predict. So I haven't gotten through question 2, but I will with the next class. So make sure you watch this video this weekend and catch it up. All right? In fact, we'll do it that way. All right, bye. Yes, question 2. Let's leave the bro off. Thank you. All right, tuberculosis causes nearly 2 million deaths worldwide each year. Now look at this. 2 million deaths. Does it say it did cause? It says causes. So tuberculosis is still killing people today. Between 1985 and 1992, cases of TB in the United States increased by 20%. Remember, we said it was going to decrease. So remember, our prediction here was that our value would be down to almost 0 by 2005, and yet here the data shows clearly that in 1992 it went up by 20%. What's going on?
The bacteria is becoming immune to
Excellent. That's right. We'll talk more about it in a second, but because of antibiotic resistance, mutations, evolution. Right? Because of evolution. Yeah.
Isn't the TB shot mandatory?
There is no vaccine for TB. TB screening is mandatory. So what they'll do is that you'll get scratched with the antigen You'll go to the hospital to scratch to see if you have, the antigen is a protein that's on the bacteria TB. It's the protein, it's not the bacteria. They'll scratch you with the protein, and then you come back a couple days later and they look at your skin. If you've been exposed to TB before, you will react. Does that make sense? So the reason they're worried is if you've been exposed to TB, tuberculosis can form nodules in your lungs and stay dormant. So you might get better, you might feel great, you think you're cured, you're running in a marathon and all that, no problem. But then later the nodules break open and they start to spread again, you get sick again. So they're worried, they don't want anyone who's been exposed to TB out on the hospital floor. We have no cure for TB. We still don't have a cure for TB. All we can do is kill the infection you have. But unfortunately, they're able to hide from the antibiotics in capsules. Yeah.
What are nodules?
They're little, I don't know if they're protein, but whatever it is, the bacteria produce this little layer of protection, and nodules are like little, what's the word that you can describe? Like it's small, like what?
Spores?
Like a spore, yeah, kind of, very similar. Could I have an ID too? They're kind of spores, yeah. Spores do the same thing, except they're much harder. But they form these little protective layers around themselves, so your body can't attack them, and antibiotics don't get it. They go dormant, and then years, a few months, a year later, they come out of it and they start to eat you again. So it's not a good disease. Hopefully the antibiotics killed all the bacteria quickly. It's possible, but that could also not be the case. So that's why they give you the test, but we have no vaccine for it. Anytime you work in a hospital, they'll do a TB scratch test. You just go in, they'll take a second, they'll scratch you, go back a couple days later, they see if you've been exposed. So that's 20% shown in figure 3. This is figure 3. TB case in the United States, 84,000 in 1953. 84 was down to 22,000 cases. 92 went up to 26,000. Still a lot less than 1953, but not zero. And if you're one of these 26,000, you think it's a big number, don't you? Yeah. Or if it's your sister, your brother, or somebody, it's upsetting. The other reason that this happened between 84 and 92 is this thing called HIV. HIV, remember, makes you immune compromised. That means your immune system can't fight off the disease. So now you're more susceptible to TB. Not just TB, a lot of different things. But that's part of the problem as well. All right, so write a graph suggesting a few reasons why this resurgence might have occurred. We just talked about that, right? I still got a couple minutes. Let me finish question 3 if I could. The resurgence lasted until approximately 1992. Then the United States, it began to abate. In 2005, TB case rates in the United States were 4.8 per 1,000. 4.8 per 100,000. So you're talking about down here by 2005. So we literally did do almost at zero like we predicted, didn't we? Even though there was a spike that we weren't expecting. As the U.S. medical community brought the epidemic under control, however, in the United States prisons all over the world, TB remains a serious health problem. In the U.S., zero-tolerance drug laws have resulted in burgeoning incarcerated population, which contributes to a significant reservoir of the disease. It's a reservoir for the disease. So in the general population, we're down to 4.8% per 100,000. In prisons, it's much higher.
But nobody moving around.
That's right. They're not moving around. What else do we know in prison? Well, hopefully it's not 30, but you're all breathing the same air. And they're close together. In some prisons, and we know we call it, in fact, there are overcrowded prisons. Our prisons are overcrowded. And the incidence rate in prisons, look at this. In the general population is 4.8. In prisons is 156 per 100,000. Considering all you've learned in parts 1 and 2, discuss why the rates might be so much higher in prison. We talked about it. It's several things. One, the people are stressed out, right? I mean, I'd be stressed out if I was in prison. 2, there's a lot of people in there all jammed together, so it's overpopulated. The food is okay, so they get fed 3 meals a day.
Okay.
It's okay. Look, if you're starving or you want to get prison food, I'll take prison food. Sorry.
Sorry.
You talking nonsense. No, that's all you're saying there. That's just nonsense. All right, so that's it. That takes care of the whole thing. Thank you for your patience. Have a great day.